Okay, so today we're reviewing Unit 3, which is collecting data. This unit is essentially just random sampling, types of samples, types of studies you can do, like experiments, observational studies, principles of experimental design, and just a lot of that stuff. And this unit basically has no math involved, so that's a good thing about it, but it's also like you have to do a lot of writing for the FRQ, so let's just get started. So I think everyone here, again, knows what 5-Hive is. I don't think I need to, like, go over that too much. The fact that there's no... Yeah, exactly. It's annoying. Make the FRQ Yes, okay. So everyone knows what 5-Hive is. Again, this AP is a trademark registered by College Board, which is not affiliated with 5-Hive. They do not endorse this. 5-Hive is the thing that is hosting these lectures and stuff. It doesn't matter. Anyway, just... Yeah, whatever. So expectations. So just please be respectful to each other in the chat. I'm putting a lot of emphasis on this. Please be respectful. Don't like go insane. Be nice to each other. Help each other out. Please be as much as engaged as possible. So if I post a poll for an MCQ, I expect a lot of people to answer. Like last time for Unit 1, not many people answered, so just try to engage with the lecture and stuff. And feel free to ask as many questions as you want to. But if like we're gonna start running out of time, I might not allow as much questions, so we can actually get through the slides and not go over 2 hours. Because I don't think we need more than 2 hours for this. Potentially for Unit 6 we might, but anyway. So this is the agenda. So we're gonna first go through introducing to planning a study, random sampling and data collection, potential problems with sampling. So this is like biases, like sampling biases, non-sampling biases, problems, stuff like that. Introduction to experimental design, like how to carry out an experiment, what are the principles of experimental design, why we experiment in the first place. And then we have selecting experimental design. So there are like various ones such as completely randomized and whatnot. You'll see them. And then we have inference and experiments. This is very short, just like scope of inference and stuff like that. And then we're going to go through to big practice. So there will be mini MCQs after like each topic, but then at the end we're gonna do like 2 practice MCQs and then 1 FRQ, and then we'll go over them together, and then we'll just have hopefully 15 minutes for Q&A. So that's the plan. Does anyone have any questions before I move on? How long will content part take? I think an hour, just an estimate. I'm not exactly sure. With questions it might take a little longer, but I plan to do an hour, I believe. Is that too long, or like I can go through faster potentially? What percent of the test is this? If I recall, like 12 to like 15%, I believe. Yeah, 12 to 15%. 15 minutes? That's too little. I gotta go before that. Wait. Did it skip a slide or something? Oh, that's not. Hold on. I was supposed to send something. So, if you need to leave early, please fill this feedback survey, and you'll also have to fill it out at the end if you plan to stay to the end. But if you plan to leave early, fill it out before you leave, preferably, so I can like look at it and just like know how to improve and stuff like that. Will there be a recording? Yes, I'm literally recording right now. Do we have to? It's better to, so I can like, you know, make the next lecture better. That's usually that's ideal, so preferably don't fill it out. Anyway, okay, I don't want to get too sidetracked. So we're starting out with 3.2. So first thing I want to emphasize before we go on, correlation does not equal causation. This is probably common knowledge, but I need to emphasize this because just because 2 things are related in some way does not mean one causes the other. So, if you do an observational study, for example, and you find that there's an association between 2 things, it does not mean those things cause each other, right? So, just wanted to emphasize that before I move on. So, when we're starting out, you have a population, right, usually? And when we want to collect data on this population, you collect a sample. And as you can see, we select randomly a few people from the population. You have to sample randomly, otherwise it will be a biased sample. So you have to select randomly, and we'll go over how you can specifically do that in future topics soon. So basically, the sample is just a subset of the population. It's not the whole population, it's just a subset of that. So it's some part of the population, right? And then in 3.3, one of the sampling methods is a census, which is when you collect data on every single person in the population. Typically, this is impractical. You cannot do this. You should not always use a census. If the population is small, however, you can do a census, but it depends. But usually you should do a sample since it's better, right? So firstly, observational versus experimental studies. So observational studies, in these kinds of studies, treatments are not imposed onto subjects. So you don't impose any treatments, you simply observe them. Hence why it's called an observational study. So you examine data for a sample of individuals, whether that be through a simple random sample or stratified random sample or not. We'll go more over these in future topics, hopefully. So if you collect data examine it for a sample of individuals, this is a retrospective study. So you're looking at data from the past. But if you're collecting data actively on individuals over time while observing them, this is a prospective study. So again, to emphasize, when you do an observational study, you confirm that there might be an association between two variables, but you cannot infer causation because in observational study, there are these things called confounding variables, which are variables that can interfere with the response variable or the variable that occurs when you manipulate one of the variables. So you cannot infer causation. So we'll go over more about confounding variables later on, but just you cannot infer causation. And an example of an observational study, you can do this typically through surveys and whatnot. On the other end, also for observational studies, generalizations, like I said, can only be made on populations, not causality. You can't infer causality through random or representative samples. And when you collect data through a sample and you confirm that there's an association between two variables, you can only generalize the data to the population that the sample was collected from and no other population. Experiments always have to meet the SRS requirement, yes. So you can actually generalize to the population. We'll go more over that later. So in an experiment, treatments are actually imposed onto the subjects. And we'll go more over what a well-designed experiment looks like in 3.5. But a well-designed experiment can show causation between two variables. So it can show that one variable actually causes the other. So yeah, so now we're going to do a quick practice question. So here's a study. So it's a study between Alzheimer's and smoking, and the scientists found that there's an association. And as per this description, is this study described to you observational or experimental? Please answer in the chats. So look at the study. Yes, thank you for making the poll. Yeah. Okay. Everyone answer, please. Ideally, as many people answer as possible. That'd be ideal. So you need to engage with the lecture, it's good. Remember, just a reminder, you can check your notes if you need to, because again, this is one of the older units, so you might have forgotten. But it seems like most people are on the same page, which is awesome. Fantastic. Now, okay, so yes, I'm gonna tell you, this is an observational study. But why? Why is this an observational study? That's very important. When it comes to these questions, they tell you to explain. Justification is that treatments were not imposed onto the subjects. The researchers were merely observed and tracked medical histories. Very good, yeah, very good. Excellent. When you respond like that, you get full credit. But when you don't give the proper justification, you won't get full credit. So like, the readers on the exam, they're very specific about, you need to be very specific when it comes to why it's an observational study. So like I said here, the full scoring guidelines, I'm not going to go through it, but essentially it is. You'll only get E, which is essentially correct, if smoking status was not assigned and was only observed. So as Yah said, yes, that is how you justify it, and that's how you get full credit. But if you only say it's observational, you won't get full credit. You can potentially get fully incorrect if you don't justify. Would we write that there is no randomly assigned treatment? Exactly, FreakPod, yes. Does anyone have any questions? Any other questions? Nope. Does this make sense? Am I being clear? Yes. Perfect. Awesome. Thank you, Nate. Really appreciate it. You could just say observational. The research didn't implement any treatment. Yes. But you need to emphasize that. If you don't emphasize that, you will not get full credits. So now we're going on through 3.3, which is now random sampling and data collection. So when you sample without replacement, okay? When a subject from a population is only selected once, so you select someone from the population and you don't select them again. You can't select them again, so you don't replace them back into the pool of the population. When you do with replacement, which you don't often do, you won't see really with replacement sampling, you'll often see without replacement. When a subject can be selected more than once, so like, it's like when you take a jar, take marbles out of a jar, then put it back, and then you select again. It's not you take them out and then just keep them out, right? So when you select from the population, you don't just like keep them, you put them back and then select again, and they have a chance to be selected again. So that's sampling with and without replacement, right? So then let's go over now sample methods. So the first one, which is very common, you'll see this often, simple random sample. This is the classic sample. Every individual in these kinds of samples has an equal chance of being selected. And often this is done through random number generators. So like you generate a number between 1 and 200, assign every person in the population to a number. If 29 selected, you select person 29, and you just repeat this until you get your desired sample. Okay? And then you can either draw from a hat. Oh, sorry. Okay, I'll slow down a little bit. My bad. Sorry. So you can either draw from a hat. You can draw, like random draw from a hat. You can put everyone's name in a splits of paper. And you can put them in the hat and you can randomly select. Or you can do this through a random number table. So you have a random table of numbers and you ignore repeats. And you assign each person in the population a number. And for every number you select, if the number appears, you select that person. So that's how you do simple random sample, right? Then you have stratified random sample. This can also be abbreviated as SRS, but you should never ever abbreviate it as that. The only thing that's abbreviated as SRS is simple random sample. You never abbreviate stratified random sample as SRS. Usually this sample method is often better, as you can control for differing traits in a population. So what you do is you divide the population into homogeneous groups. So you divide them into similar groups. So in each group, they have a similar characteristic you base them off of. Like for example, height or weight, for example. So everyone in that group has a similar characteristic. But across each group, they're different. So you call these groups stratas. And then you take an SRS within each strata. So within each strata, you do a simple random sample. And you do this in each strata. You can select 2 or 3 within each strata. And depending on the number, that'll give you your sample with a specific number of people. Right? Then you have cluster sampling. This is different from stratified random sampling in how the groups within each group, everyone is different between, but the groups from group to group, they look similar. So they're not often based on a certain characteristic. You just cluster the population off with some amount of people. They don't have to have a shared characteristic. Therefore, between each cluster, it'll look similar. And then what you do is you take a simple random sample of all the clusters, and then the selected clusters, everyone in those clusters, you end up sampling. You sample everyone in the chosen cluster. So you can see in the screenshot here, that's how a cluster sample would look like, right? Then you have systematic random sampling. This is the easiest kind. What's the difference between stratified and cluster? I explained it a little bit, but I'll explain it again. So stratified, you divide the population into similar groups. So within each group, everyone has a similar characteristic. So everyone has the same height, similar heights maybe, or a similar weight. But in a cluster sample, everyone in the group usually has a different trait. And therefore, because it's random, every group will look similar, but within each group, everyone will be different. Right? Does that make sense? Perfect. Okay. I don't want to dwell too much because I want to have time to, do the practice questions and whatnot. Okay? So systematic random sampling. You start at a random point in the population and you select people at fixed and periodic intervals. So you select X person every 5 people. So you select this person. So you start at the 10th person. Then you select the 15th, 20th, 25th, and so on. So you select them periodically.
Muted. Unmuted.
Right? And that's all in terms of sample methods. So now we're going to do a practice question. This shouldn't take long. So this is the practice question. And given that context, describe one statistical advantage. So you need to describe a statistical advantage of using a stratified random sample over a simple random sample. essentially why a stratified random sample could be better than a simple random sample. So you got to read the context and then explain accordingly. So I'll give a bit of time for this. Let me see something. Okay. Okay, I'll give a chance for more people to respond. Remember, friendly reminder, you can check your notes if you need to. Hold on.
Muted. Unmuted.
Yes. Okay. It seems like everyone's on the same page, which is awesome. Everyone gets the question. Okay, oh, my bad, Dragonfire. Next time, please put spoilers, because, yeah, you don't want to spoil the answer for anyone. I forgot to do that. That's completely my bad. I'll make sure that we have spoilers for them. Yes. So for the people who now answer, how do you do spoilers? You use this character, right? That character, and then you do another one, and then you put letters in them. You put words, beautiful words, and then you hide the words. So, okay, yeah. I think everyone's on the same page. So yes, an advantage of using stratified random sample: equal sampling of each grade level. So you can equally represent in the sample each grade level, whereas if you do a simple random sample, you could have more elementary schoolers or more middle schoolers. Exactly. You don't guarantee that each grade will be represented in the sample. Awesome. SRS doesn't guarantee this because you select randomly without separating them. So in a context where you have a shared characteristic between some people, like a grade level or some kind of height or what have you, it's better to do a stratified random sample so you control for that and you have an actually representative sample. Whereas if you do an SRS, you risk not having that, unfortunately. So now we're going to go over potential problems with sampling. So like what could happen if you do some kind of bias sampling. Thank you, Ray. Really appreciate it. Okay, so bias. Bias is when certain responses are systematically favored over others in some way. So some responses are favored than others due to some kind of error in selecting the sample, essentially. That's what bias is. So firstly, non-sampling errors. So you can have non-response bias where when you sample someone and you can allow them to voluntarily respond, they refuse to respond, and thus you can't get data from them. And it differs from individuals that do not respond, meaning that when an individual doesn't respond, when you have the option, when you give the people an option to respond or not, when you give them that option, the people who do respond will often be people with extreme opinions or actually care about responding. But the people who don't respond are going to be the people with mediocre opinions. And thus, the data you get might be actually exaggerated, unfortunately, is what happens. Then we have response bias. So you have two kinds of biases here. Question wording bias, which are essentially just confusing or leading questions that lead you to answer something, which can favor certain, which can skew the data a little bit. And then you have self-reported responses, so individuals might exaggerate their responses to make them look better about themselves. So if a survey asks how much times do you exercise in a week, people might say, oh, I exercise 7 times in a week, when we know that is probably not true, and people are exaggerating that. So when you have that, people are exaggerating, unfortunately. So that's a bias that you could have. Then we have sampling errors. So using a non-random sampling method automatically introduces bias. So the people in the group might have some large majority of one group but not another. So voluntary response bias, when individuals choose to participate. So like I said, when people choose to participate, it will not be representative, like I said, because they'll have an extreme opinion often than the people who don't respond, which have the moderate opinion. That is often the majority. But often the lower majority will have an extreme opinion. So, and then you also have convenience sampling. So you choose individuals in a way that's seemingly convenient. So an example of this is you sample the first 10 people that enter a convenience store. Or a teacher samples everyone in the classroom. When the problem with that is the people who walk into a convenience store, or the people in a statistics class, for example. When is the AP statistics exam? May 8th. Yeah, so it's pretty soon. Anyway, so like convenience sample is just when you select people at your convenience. So if you just sample people in a statistics classroom, that might not be representative of the people like who are actually in the high school. So like not everyone takes statistics, not everyone takes psych, not the same people. So it's not representative. So you got to take a random sample for that reason. And then there's undercoverage bias, which is when not everyone has the same chance of being in the sample. So when you deliberately make it so, for example, when you sample people with telephones about their voting opinions about some candidates, when you do that, you don't represent the people who might not have telephones or might not even have their phone numbers listed in a phone book, for example, or something like that. So when that happens, you get a biased sample, so it leads to an unrepresentative sample. So these are potential problems that you could have. So, practice MCQ, quickly. Can someone make a poll real quick? Just A, B, C, D, E. When you're designing a survey, which of the following best explains how to minimize response bias? I don't think this is too difficult. I think everyone should be on the same page here. Unless not. Thank you. Oh. Vote on Omer's poll. Also, two things. One, check your notes if you need to. And two, I see some people are leaving here and there. So if you're planning to leave and not coming back, please fill out the feedback form that I sent above. I will send it again just to make sure people do that. Because ideally, I want as many people as possible to fill it out so I can actually know if I'm doing a good job and stuff like that. So here's the feedback form again. Fill out the form every day. It's ideal. It benefits us lecturers, so we know if we're doing a good job or not. Let's see how many people voted. 14. Okay, that's probably enough. Okay, so there's some mixture in the opinions, so I'll go over this. So the answer is E. Carefully word and field test survey questions. So remember in the previous slide, we went over the biases. So if you look here, one of the biases is question wording. So when you have wording in the questioning, that when you have some kind of bias in the questioning, when it's a leading question, when it's influencing you to answer something, yeah, the keyword is response bias. So when you do that, that can introduce bias. So that's how you minimize bias. Increasing the sample size has nothing to do with minimizing bias. Like, how could you, like, people, in a big sample or a small sample, there could be still bias. So if it's in a big sample, for example, let's say it's a big sample, you can still have bias if the questions are, like, still leading. Decreasing the sample size is not relevant. Randomly selecting, that doesn't necessarily reduce bias. It's simply, what that simply does is it allows you to have you can generalize the results to the population. Bias occurs when you have poorly worded questions. So yeah. And then D, increase the number of the questions. That is completely irrelevant. You can throw that out the window. So it's E. Does that make sense? So like the most common thing you could choose is C or E, but it's E because it's about response bias. You minimize response bias. Exactly, yeah. So it's not minimizing general bias, it's minimizing specifically response bias. You need to know your vocab. You see here, response bias, question wording bias. This is directly in the CED. So yes, awesome. So now everyone's on the same page. Just flip a coin at this point. No, if you know your wording and you know your things, you will do good on the MCQs. Trust me, okay? Unit 3 is hard, but if you just know your content, then you should be fine, I hope. Okay? You just gotta know your content and know, yeah. Like what? You're dangerous on phone, addicting phone versus outside life? Yeah, perfect example, Omer. Very, very helpful. That really explains it well. So yeah. See guys? You need to like, bro. No, you need to actually help out people. When you give examples and stuff like that I don't give in the lecture, people actually benefit, right? So now let's go to experimental design. If I'm not mistaken, this lesson is quite long. This topic is a little longer than the others. So why do we experiment? And why don't we just survey everyone and call it quits? Why we do that? So we can infer causation. Like I said before, observational studies, you cannot infer causation between the variables. Okay, just before I continue, please be respectful in the chat and don't slander each other. Focus, actually listen. Okay, back to what I was saying. We experiment, like I said, to determine causation between two variables. When we infer causation, and observational studies do not infer causation because they introduce confounding. So here we say experiments control for confounding variables, which are, like I said, variables related to the manipulated variable that also influence the dependent variable. So in an experiment, you minimize these variables so that you can actually attribute the manipulated variable to the response variable. right? So it's kind of like the XY variable, the independent-dependent variable. So when you have an observational study, the independent-dependent variable connection is really bad because there are other variables that are contributing to influencing the dependent variable. So it's dependent not just on the independent, but it's also dependent on other things, right? So like you see in the screenshot, there's a confounder. So healthy heart rate, like if it's all, you can all attribute it to exercise, but you can also attribute it to healthy eating. Wait, why are you confused? What's wrong? You understand now? Wait, Super Dancer, why are you leaving? It's okay, because it will be recorded. I'm recording right now. Yeah, it's recording and didn't stop. So it's more than one action relating to the effect? Perfect. Yes. Awesome. That's what it is. That's all it is. That's what confounding variables are. And remember, guys, you can explain if I don't have time to explain, like for you guys that understand and stuff like that, because there's plenty of people here for you to explain and stuff like that. Okay? For example, research wants to test coffee improves test performance. They divide the study. Coffee before the test doesn't drink coffee. They compare tests of both groups. Confounding variable is what if they didn't sleep? Yes. Yeah, you're doing awesome. This is perfect. Text answer: confounding variables can potentially manipulate the result. Yes. Think we all get this? Yes, I think we all are on the same page now. So the components of an experiment. When you design an experiment, this is what you have typically. Firstly, the individuals in the experiment, you don't call them individuals. In AP Stats, we call them the experimental units. I know it's such a fancy, pretentious name, but that's what you call them. The individuals that are assigned treatments, when you assign them treatments, or like the things that, influence the dependent variable. So it's the independent variable that leads to the effect. So people are often, when you use people as experimental units, you can call them participants or subjects. But when you use animals, you can call them just experimental units. They're not participants, they're not really subjects. Then next, you have the explanatory variable or the factor. This is just also known as the manipulated or the independent variable. And the levels of that, the varying levels of the independent variable, those are the treatments. So you can either give the participants maybe a drug that helps improve some kind of disease, or you can give them a placebo, which is what often you give, that does nothing. That just does nothing. So that's the explanatory variable. The explanatory variable is just the treatment that you give them. So it can either be like a pill, both of them are pills, but one of them actually does an effect, the other doesn't. Does nothing, but the people pretend they're getting something. Yes, we'll go over placebo effect later. I was just giving that as an example. Response variable is the measured outcome from experimental units after treatment. So that's just the effect that you have. So like the effect, for example, in our example before, so when people take the drug, the effect is if they actually improve. With the placebo, they often won't because it does nothing. But the actual treatment, we measure if it actually did something. So in an experiment, you can infer that causation because we hopefully control for the confounding variables. So we'll go over how a good experiment looks like. I just gave you the pill to cure cancer. Feel any better? Okay. Principles of an experiment. So the principles of experiment are four main things. Firstly, you have to do comparison. You can't just do it to two people and call it quits. No. You need to compare it to multiple people. You can't just give the treatment to one person and see what happens. No. That's terrible. That's just terrible experimentation. You need to do with multiple people so you can average out the effects, the confounding variables. So like if you do it on one person, there could be a confounding variable where maybe something, I don't know. But if you have multiple people, all of the confounding variables, all of the personal variables balance out. And so you can actually attribute the treatment to causing an effect. So the effect averages out. I've tested it on zero pulpit and make a conclusion. Terrible design. That's a terrible experiment. Yeah, no. That's terrible. Bad idea. Then you have random assignment to groups. You need to randomly assign people to groups, whether they get a treatment or they get a placebo, or they if you vary them to if they exercise or not, whether you're trying to do something. Yeah, you need to do random assignment to groups, right? And then you need to replicate to multiple. Oh wait, actually I made a mistake. Comparison, it's to two groups. Which means just two groups or more, like one gets a treatment, one doesn't. Yeah. Replication, it's fine, don't worry, this is recorded. Don't worry about it. What did I miss? You missed a bunch of topics, but don't worry, this is being recorded. Right? And I need to move on. I can't accommodate for only one person. I'm sorry. But I will send you, the lecture will be uploaded hopefully, and it will be much better than the last one, which was kind of laggy. Anyway, back to what I was saying. Replication, you replicate it to multiple experimental units, multiple people. Like I said, that reduces chance variation, or the chance that one person, has a confounding variable that everyone else doesn't have. So it balances out. Then you control the confounding variables. That's one of the principles you need to control for the other variables that can affect the response variable. So you need to control those so that the independent variable, dependent variable actually make a link, and you can infer causation as you normally would in an experiment. So now we're going to go over experiment designs and methodologies. Where will the lecture be uploaded? It'll be uploaded on the lecture calendar, I believe. It'll be uploaded on the lecture calendar. It'll be there, so you can see Unit 3 lecture, MG8, you'll be able to see the video. Perfect. Yes, that spreadsheet. Okay, experiment designs and methodologies. So you first have completely randomized design. So here, you randomly assign firstly, you get a group of people together. Ideally, you randomly sample them, and we'll go over why that's important soon. You get a group of people. Then you randomly assign them to two groups. The first group receives one treatment, the second group receives another treatment, and then you compare the results, right? That's a completely randomized design. You completely just randomize the groups, you assign them, and that's it. And each one receives the treatment, and you just compare the response variable. You compare the effectiveness. You can compare it to placebo, or you can compare it one treatment or another treatment and see which one is more effective. I remember for the unit test, we're supposed to actual diagram for the exam. You can either explain it verbally, so you say we have a random assignment, we assign them to two groups, we give them both respective treatments, and then we compare them. You can do that, or you can draw a diagram. Do not explain. What? No, you need to explain it. Even if you draw a graph, you still need to explain, because if you just drew the graph, you won't get full credit. You need to actually put the explanation. I'm sorry, yes, you will need to explain. It's annoying. The people who write the exam are, yeah, it's annoying, but that's Unit 3. You have to put up with it, unfortunately. So like I said, random assignment, what that does, balances confounding. And this is, like I said, either done through, as we saw with simple random sampling, you can do random number generator, a hat draw, or something else. And just for fun, I'm going to ask, what other things can we do in terms of random assignment? Both groups get treatment? Yes, you need to give both groups some kind of treatment. So what other ways can we do random assignment, other than like a random number generator or a hat draw? So there are other ways we can do random assignment. Flip a coin. Yes, you can flip a coin. That works. That really works. Putting everyone in a washing machine, that doesn't work. Russian roulette, no. No, this is not the Russian mafia. You don't shoot people and kill them. That's not how that works. Slot dice, sure. Yeah, no. No. Slot, guys. Okay, this has gone off the rails. No, okay. Bad idea. Now we're going over placebos. Like Ray brought up earlier, now we're going over placebos. The placebo effect is when the experimental units have a response to a null treatment that does absolutely nothing. So you give them a treatment like a salt pill or a water pill. That it's disguised, it's in a capsule, so it looks like a treatment, but when you give it to them, it's supposed to do nothing. But the experimental units have some kind of response anticipating that, oh, it's a treatment. So their belief in the treatment manifests some kind of cure. That's the placebo effect. So the null treatment is just a placebo, which is just some kind of like salt pill or something that just does nothing. Nothing at all. It is absolutely useless. Friendly reminder again, if you're leaving early for the lecture, please fill out the feedback form. If you're planning to leave early, I will send it for the third time because I want everyone to fill it out. Ideally. Because I want your feedback, and your feedback is extremely valuable to me. Okay, guys? Moving on. Blinding. You see a blind man here. We do either single or double blinding. The subjects or the researchers, either or, don't know which treatment is real or is this placebo. So either the researchers give the experiments a random treatment that they don't know what it is, and the experimental units know what it is, that which is the treatment, which is the placebo, but the experimental researchers don't know. Why we blind the researchers? Why would the researcher not know? Well, the researcher might not know because if they know which treatment is which, they might introduce some kind of experimental bias because they want the actual treatment to work. They want the treatment to work. Maybe it's their treatment or something like that. That's why you might want to blind the researcher. Of course, you blind the experimental units, right? Yes. AP Psych. AP Psych and AP Stats do intertwine a lot. That's nice. Anyway, going off the main point. So the double blind, when you blind both. When you blind both. And the reason why you would blind the experimental units, on the other hand, is because you might not want them to have the placebo effect. So you don't want them to know which treatment is which so that they don't have the placebo effect, and so like you can actually like not introduce bias in that regard, right? So now we have the awesome randomized block design. This is my favorite kind of experiment because it is the stratified random sample. If you wait, no, we'll go over it together. It's gonna make sense. No, wait, don't panic, don't panic. It's all gonna be all right. It's not as complicated as it looks. This is a very handy graph. So you guys can see my mouse, right? Just to make sure. Can you guys see my mouse? Yeah? Perfect. So you start off with the subjects. But instead of going directly to random assignment, randomly assigning it to groups, you block them off. And why you block them off is the same reason why you do a stratified random sample. So you block them off not randomly, but based off of a certain characteristic. You can block them off of gender, block them off of height, block them based off of, I don't know, something. But those are just some basic examples. But often you block based on gender because maybe those two have some kind of different. Chat, am I block 1 or 2? That doesn't matter, it's not relevant. You block into strata, kind of. But you don't call them strata, you call them blocks. So in each block, everyone has a similar characteristic. So these are called blocks, and what they do is they reduce variation. So if you just put everyone into two random groups, so like one group has males and females, that can introduce, that might cause confounding because gender might be a confounding variable for why one treatment works better than the other. So to minimize that, you create two separate groups to compare the effectiveness in two separate groups, right? So you see how the effect is on males, for example, or on people with a certain height if you're doing something, or feet size, if you, for example. And then block 2, you do the same thing, and then you randomly assign both blocks into random groups, both 2 groups or 3 groups, depending on how many treatments you have. You do this in each block. So here, it's the same thing as randomized block, except randomized design in each block. So you carry out a randomized design within each block separately. Okay? Do we not compare the last 2? I'll get to that. I'll get to that in a second. Just bear with me. So then you compare the 2 groups, you give them the treatments, and then within each block you compare the response variables. Okay? And sometimes you might want to merge the results, but oftentimes you don't want to do that and you just want to keep them separate because the results might be different. So you break a large population into 2 groups based on different factors and individually test the experiment. Yes, you block them off. And on the AP Stats exam, when you're asked to block, you must justify why you're blocking the variable, why the blocking variable affects the experiment. You block the most influential variable? Correct. Yes. You guys are very helpful. I very much appreciate it. You guys are helping me explain and stuff like that. So give a reason. You have to. Yes, you have to give a reason. If you don't give a reason, you don't get full credit. They often say, why are you blocking? What are you doing? Why are you blocking? Why aren't you just doing a randomized block design and calling it quits? You have to explain. You have to. Always. On the AP Stats exam, you explain everything. Because if you don't, you won't get full points. They want you to explain everything. So you gotta be very picky about that. Right? So you gotta make it a habit. So when you're practicing, you gotta explain everything. How am I supposed to do that within 15 minutes? You gotta learn how to be fast. Right? And you gotta be efficient. You don't have to write a whole paragraph, but you have to be efficient. And you have to just practice, which is why we're doing a lot of practice in this presentation, in this lecture. Okay. Matched pairs design. This is a very interesting one because there are 2 kinds. You can either do similar groups, so you have the pairs, right? So you create pairs, so you grab a population, right? And then you divide them up into pairs based on a similar characteristic. So these 2 might have the same height, may have the same metabolism. They might even be biological twins. They might even be full identical twins, right? Or they can be some kind of twins, right? That's why it's called matched pairs design. So it's basically you grab twins and then you randomly assign them each into groups. So each of them, so in each pair, so each group is a pair, and each pair you give them a treatment. So you flip a coin and randomly give one this treatment and the other that treatment, right? And then in each pair you compare the response variable, you compare the results. Now, you won't often see this actually on the exam. What you will see more often is the matched pairs you versus you. So you're the pair. in that sense. So everyone's randomly assigned, so everyone's the matched pair. So you give you give yourself one treatment, and then you give yourself the second treatment randomly. You won't know which is which often. Or you could go to the second group where you get the second treatment and then get the first treatment. So the order you get the treatments is different. So you're the pair itself and you get both treatments, but the order you get them is completely randomized. It's completely random for each person in the experiment. And then you compare them. Wait, what's so confusing? What's so confusing about it? Remember, you have plenty of time actually. Don't worry. Flipping the order, yes. That's what you do for each person. So all the people take all the treatments? Yes. Everyone is a group. There are just 2 groups because you cannot just put 10 groups in a model. That's really difficult. So every person is a group. Pretty good, I think. I think the pacing is pretty decent. We're almost done. We're almost an hour, and we're almost, I think, done with the material. And we're getting time to do questions and stuff like that, so we're doing pretty good here. Right? Can someone give me an example on when this kind of design would be useful? If you have twins and they're similar to each other, or you have 2 kinds of treatments where each person needs to take both treatments. We'll see an FRQ that might apply to that soon. Just bear with me. You'll see how it might apply. But it might apply where you have 2 treatments and every person needs to take both. It's not like one person goes into a group, they take one treatment. No, it's a scenario where everyone needs to take treatment. So maybe, let's say, you need to test both pills and compare the effectiveness of them. Really? Aw, thank you. Researcher wants to test a new memory training program, improves memory training. Recruits 20 persons, randomly assigned to 2 groups to reach your pairs based on similar traits. Each person, yes. That's a good scenario. See? Guys, when someone asks a question like that, I don't have to be the only one only as answering. You can give an answer, and you can just say, this is an example of a match pairs design where it'd be useful, where it'd be applicable. So you can do that, see? Y'all has been very helpful in terms of that. Good job. Good stuff. Helps control confounding factors? Yes. That is the whole point of experiments. Always. You do these things so you can control for the confounding variables. So you can actually create a causation. That's the whole point of experimentation. That's the whole essence. That's why we don't just have observational studies. We want to determine causation between 2 things. We don't want to just have associations. That would not benefit anyone ever. So they do 2 tests? Yes. Kind of. But does this make sense to everyone? I think we're all on the same page. Everyone gets this stuff. But I think this hopefully makes sense. And they compare the results? Yes. Between each person. And then here, in this case, you do it for every twin. For every pair. Here, you do it for every person, and every person gets the treatment. But here, you get 2 similar pairs, and one person gets a treatment, the other person gets a treatment in each pair. In each pair, both people get 1 treatment. So it's not like groups. Think of it as subject name, same experiment, but different order, yes. Also, my AC is on, but I'm sweating. I don't know why. Not relevant. I just had to say that. But we're almost done, I think. That's funny, yeah. I turned on my AC so that my PC would cool down, so the lecture recording doesn't get laggy. Wait, let me, it's on cool. I'm gonna turn down the temperature to 19 degrees. Oh my god. I'm boiling alive. Yeah, OBS is working to AP stats is too hot. Okay, I don't want to dilly-dally too much. Let's move on. We're going to 3.6. We're almost done, guys. 2 more and we're done. Okay? Is this making sense to everyone? I think everyone seems to be making sense and everything. Why would you divide individuals then? To control for confounding. Basically. Use Ice Bucket Challenge PC. That would destroy my PC. I've had this laptop actually that I'm using for 4 years, by the way. I've had it since 2020. Use nomination. USC nomination. I have not been nominated yet, unfortunately. My friends have, though. Anyway, not relevant. 3.6, by the way? Can I nominate you? Maybe. I mean, go for it. Sure. If you get nominated. Okay. I mean, I would really like to use an Ice Bucket Challenge right now because I'm boiling alive. Oh my god. Okay. Selected an experimental design. Practice. This is a practice lesson. All this is just give it the situation. you use different experimental procedures. You don't always use stratified. You don't always, not stratified, sorry. You don't use randomized block. You don't always completely random. You vary it. Depending on the scenario, you have to be a smart guy. Look at the question and see the scenario and pick. So you gotta do that. Otherwise, if you don't pick the appropriate scenario, you will not get full points. You might get P or I even. To get E, you need to pick the correct scenario. So you gotta use your statistical analysis to pick the right scenario. Okay, so now we're gonna do an FRQ. Quick FRQ. Read the scenario, design an experiment for this procedure that uses 100 volunteers, include a few cents on how it be implemented. Preferably, pull out your notebooks, write the explanation down, and create a graph, and if you can't, send it in the lecture channel. If you can't, that's totally fine. We'll go over it together and see if you guys are right. So I'll give you guys, how much time would be good for this? Because, like, I think 5 minutes? That seems good. And I added an extra part. You need to explain why is that method the most appropriate for this design, for this scenario. You gotta explain always. This is training you to make sure you know what you're explaining. You don't just do something random and it's like, oh, I'm just gonna do that because why not? No, you gotta explain. You gotta know what you're doing. You gotta know what you're doing. Am I yelling too much? I might be yelling too much. Is the problem. Yeah. But yeah, I'll give you guys 5 minutes to do this. Okay, I'll tone it down a little bit. I'm sorry. I don't know why. I'm just getting really passionate for some reason. I'm sorry. I was just getting into my elements. I'll tone it down. I'll tone it down. I'll tone it down a little bit. I'll calm down. That might be why I'm like boiling alive. Okay, I'll give you guys 3 minutes because I think 2 minutes have passed. I'll just say 3 minutes to do this. Yeah, I love this class because it makes sense. Friendly reminder, check your notes if you need to. And for the 4th time today, lecture feedback form. You can say, this guy was too loud. I don't like this guy. He's too loud. He's too annoying. Be fully honest, but please be nice. Like, tone your voice down. Don't say, oh my god, he's so aggressive. This guy is, don't attend his no. Please be nice and be constructive so I can improve for tomorrow. Tomorrow we're doing Unit 6, hopefully. So I recommend you guys attend that, right? Are you guys solving the question? Just making sure. So I don't want you guys to just, like, sitting around. No! Stop! Oh my god! Why? Wow! Oh no! Oh my god! Why are you guys doing this? Okay, let me look at the answers. Give me CSA lectures on one-on-one. I suck at CS. Do you do CSA also? I plan to do CSA this weekend. I hope. So on like Saturday, I plan to do Unit 3, Sunday Unit 4 maybe. But the problem is, like, I'm doing a lot of lectures because this is fun and I just really want to, like, just have something to, like, yeah, I want to do a lot of lecturing just to, you know, lock in. But, like, the problem is, I don't want to sacrifice my sleep too much because the problem is, I live in Jordan and so the weekends here and there in the US are not aligned. So if I do it on Saturday, I'll probably get 4 hours of sleep. And then on a Sunday, I'll get not many sleep. Yeah, you know what? Maybe screw sleep. Yeah. Helping out people, explaining stuff, it's worth it all. All this is worth it because when I explain to you guys and you guys listen, we're all gonna get a 5. You hear me? Everyone who's in this call right now, we're all getting 5s. We're all getting 5s. 4.9. Imagine. 20 seconds left. So only 2 people responded. Unfortunately. You guys are just like goofing off, doing whatever. Just talking to me, listening to my voice. I don't know why. Like, do the question. Like, if you did it on your paper, excellent. Only good boys will get 5s. Everyone here is great. That's why people said on my last lecture. And I got a 4. Oh, man. Hold on. Wait. Alright, time's up. So, here we have the answer. A paired design or crossover design is the best option, right? So it's either subject would be randomly assigned to one of two groups. Group 1 would have the new method applied to the right foot. Group 2 would have the new method applied to the left foot. For each subject, whether the new method is applied to the right or left foot, boots is determined at random. Or a crossover design, in which each receives a pair of boots, both of which were treated with one treatment. The boots are used for 3 months and then exchanged for a second pair of boots, both of which were for the other treatment. So this one's kind of weird. I don't like it too much. This is the first match pairs design. Wait, is this the doc, just the slides, not the recording talking? What do you mean? Okay. Is this one the FRQ? Yes. Nate, shut up. Anyway, so the first one, you can either, answer this really beautifully. You can either do treatment 1 where left foot, new method, right foot, old method. I think you might have probably done this FRQ before, but it's fine. It's all good learning. If you want to look at what he said, what he answered, please do. It's really good. And then the treatment 2 is right foot, you do the new method with the new boot, and the left foot, you do the old method. And then in both treatments, you compare, and then you compare between the two. So when you look at the scoring, you notice that some people did completely randomized design, and while that's okay, that's a P, that's not E. So, wait, he means the doc contained the presentation only. I think it's the screen recording also with his Gloria foot. Yeah, the doc contains the presentation, and yeah. Wait, is it that doc just the slides, not recording of the talking? Wait, no. The recording will also be with my voice. Don't worry. Right? So notice here, when we see here, if you look here, you need to make sure that it's a paired design to get an E. But if you say complete randomized, that's okay, but it's not like the score you're looking for. If you want an E, you gotta say match pairs. Why is match pairs design? Because, as Ya said, it controls for confounding between the, hold on, let me just see what he said. We create match pairs because there might be confounding factors in the differences in usage, different exposure to water. So like, if one group receives the new boots and then one group receives the old boots, both groups, there's a confounding variable in how much water gets exposed, right? But if we do one boot at a time, we balance out the water exposure between them. Mixed nuts are so good. That's true, honestly. I always bring nuts to school, pause, and they're really good. Yeah. I especially like, bro, who the heck is gonna wear one boot, bro? I don't know, you tell me. That's the experiment. I see some people leaving for the 1 billionth time. This. Lecture feedback form. Lecture feedback form. Lecture feedback form. Please give me feedback. I want feedback. If I didn't make that clear enough already. Moving on. This is the second pair. You can do the new method for 3 months, then the old method for 3 months. And then 3 months, 3 months. This is a crossover design. We don't really need to learn this. This is really weird. If you say this, you get an E. This one is, like, it's fine. It works. It'll get you the score. The good score. Now, final topic. This is really short. This is just scope of inference, essentially. How we do inference. And then afterwards, we'll do an FRQ and 2 MCQs and an FRQ, and then we'll have a lot of time for Q&A. So we're almost done with the material. So I think I paced myself well, like an hour. I think I did a good job on that. Awesome. So that's really good. And it's recording. Short, 3.7 is similar to me. No, it's just one slide. Just one slide. Now let's go over this together. It's just statistical inference. So it's just conclusions made based on data generalized to sample's population. So when you randomly sample, right? When you sample, you can only generalize to the population that you selected. This is why when you do a convenience sample, when did this lecture start? An hour ago, 9:30, 9:38. We've been here for an hour. What do you mean, buddy? I'm not in your time zone. Oh, no, we've been here since 2:30 p.m. EST. No, Nate, stop hating. Stop being a hater. Everyone here is awesome. Okay? You guys are all awesome. I love you guys. Not like that, though, but you guys are all awesome. Thank you to everyone still who's been sticking here. Everyone who stuck years ago, everyone who left is also great, but I'm sad they left because the more the merrier, you know? Anyway, statistical inference, like I said, conclusions made based on data generalized to sample's population. So sample must be representative of said population. It has to be, and the way you do that is you do through random selection. You have to do random sampling to ensure that that sample is representative of said population. Because if the sample is not representative of a population, what are you going to generalize it to? How are you going to generalize it? That makes no sense. So if you select a sample from a population, but it's not random, like you select a bunch of people who are like 18 years old and you don't vary the age, for example, you can't really generalize to 20-year-olds, 30-year-olds. You can only generalize to 18-year-olds. And if you don't do a random sample, how are you going to generalize to all 18-year-olds? So you need to randomly select so that it is a representative sample of the group you're choosing, so it can be generalized and you can actually make generalizations. And then that allows you, so when you do a random sample, the scope of inference is that it allows you to do generalization. When you do random assignment in an experiment, you can actually make conclusions. So if you do an experiment but you don't do random assignment, that nullifies your ability to make conclusions. You can't make conclusions. So observe, which when you do that, it means that the observed changes are so large that they are very highly unlikely to occur simply due to chance. That means it's statistically significant. And statistically significant difference, treatments cause the effect. So if there's a statistically significant difference, that means the treatment actually caused the effect that we're looking for. So that means we made a conclusion and we can actually say the treatment did this. And we don't have to say this, some other thing did that, or some other, yeah. In an observational study, you don't do random assignments, so you cannot make causation. Unit 3 explains so much of Unit 8? I guess so. I don't know. I'll have to take a look at Unit A and see what you mean. But maybe. But if it helps out, that's great. So now, we're done with the content, guys. We're done with the content. But now we gotta do practice. Isn't that like tests? Yes. Unit A specifically is chi-square tests and whatnot. Oof. I also kind of need a break, so it's good that you guys are gonna do practice and I can just, like, relax for a bit. Oh my god, that was a lot. That was a lot. But we press on. We're almost done. You just gotta do practice. So we're gonna do an MCQ. Someone please make a poll as always. Nate, my man, if you can make a poll, that I'd really appreciate it. Or someone else, please. Why are you saying meow? Someone make a poll, please. That'd be excellent. Just waiting. Yeah, Nate, make it faster. While we're at it, I'm just gonna read the question to see what we're doing. Cover designs for the city. So remember, this is related to our scope of inference if you want a hint. Nate is AFK. Oh, you forgot to put E. Ugh. I'll make the poll. I'll do it myself. No, it's fine. Don't worry about it. I don't mind making the poll. It's just easier when someone else does it for me. You know? So I don't do all the work. All the bad work. Busy work. You know? It's good when you have other people doing things for you. It's helpful. You delegate stuff. You know? Makes things better for you. So you gotta always, like... You know that Eisenhower, like, square thing? Like, when you delegate certain tasks. And someone made it wrong again. It's okay, it's okay. It's okay. See? Sometimes you gotta do things yourself. Nah, I'm kidding. Don't worry, don't worry. It's okay. Holy moly! Why? I swear to God, I put E. It's fine. It's fine. I don't know why people are leaving. Okay, everyone please vote. I think some people are AFK. That's alright. One sec. Chat, we just slow today. Oof. Okay, let's go over the answer. Let's see if you guys are on the same page. Most people are on the same page. Excellent. but I'm going to explain for the people who picked the wrong answer because, learning is learning. So don't change your answer. Keep your answer the same. That's an L move. Own up to your answer. It's okay. We all make mistakes. I also make mistakes, believe it or not. Who's changing their answer, man? Stop. Keep your answer the same. Stop, bro. Stop. Please. Keep your... Anyway, it doesn't matter. It doesn't matter. So the reason why it's not C is which of the following gives the conclusion that should be made. So, the reason why it's D is because we can make a conclusion that the difference in sales was caused by the difference in cover signs. So we can infer that the response variable was caused by the treatments. Why? Because the cover signs were randomly assigned to the source. Like we said earlier, when you do random assignment, your scope of inference is causation. But when you do random sample, your scope of inference is not causation. Causation is contingent on random assignment to groups. But your first scope of inference, when you do random sampling, you are able to generalize your results to a bigger population. So the reason why it's not E, different covers because the sample size was large, that's not relevant at all. So the not reasonables are not reasonable to conclude because this was not an experiment. It was an experiment because they did random assignment. So if you read the description, this is clearly an experiment, no doubt. To conclude the difference in sales, because there was no control group for comparison, there were two groups for comparison. So we did fulfill comparison, so it is a good experiment. So we can conclude. And reasonable not to conclude because the 70 stores were not randomly chosen, this is not relevant. The 70 stores, regardless of whether they're chosen, we might not be able to generalize to all stores, but what we can do is make a causation. We can make a case for causation because we randomly assigned. Okay? Is correlation for random sampling right? What do you mean? But did that explanation make sense? Yes? Did make sense, yes. Perfect. That's excellent. For the people, if you're about to leave, I'm going to send this for like 16,000th, 1 billionth, 16th squared cubed quadric time. Please, 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 please fill out the lecture form. Feedback. I don't want to go open it and see only 3 responses. Second MCQ. You gotta read this and determine what it is. What the experiment is. What kind of design is it? People actually fill them out? Yeah, people do. Please do, though. I really encourage you to. Technically, you don't, but it's really helpful for lecturers like myself. Nice! Everyone give a hand to Niskow. He actually made the poll right. Close enough. Yeah. Wait, let me just check what the answer for this one is, because I kind of forgot. Luckily, I have the, Okay, yeah, makes sense. That makes sense. Nishal? Okay, Nishal. Got you, bro. Got you. I'm done with you. Man, Stu. Such you. Please answer, guys. Please vote. Please vote. Please don't not vote. Please engage with the lecture. It's very helpful. It's very nice. It's very awesome. Please engage with the lecture. Please, please, please. And another reminder, check your notes if you need to. Remember, you can check your notes for an experiment, observational study. My lecture slides are great. They're awesome. I mean, yeah. But you can also check your notes. I encourage you to do that. You can check your notes. You can check your notes. Okay. Usually A-push, there's 5 people an hour in. Oof. So, I think people leave early because their attention span is not the best. Guys, wait, how many people answered? I got distracted. 9! Awesome. Let's see if we're on the same page. There's some disputes, but I think most people are on the same page. Yes, it's A. Let's go through this together. So we see here, we're trying to see the effectiveness of 2 laundry detergents. So already, we're thinking, we want to compare these two. Which one's more effective? That's the question. As each dirty towel is turned in, it is placed into the only washing machine on the premises. So there's one washing machine. When the washing machine contains 20 towels, the manager flips a coin to determine whether detergent A or B is used for that load. So as we can see already, there is some kind of random assignment using a coin. So as someone said earlier, you can use a coin flip to randomly assign instead of like a hat draw or something like that. So you can definitely use a coin. This is an example where you can use a coin. You flip the coin and then you randomly assign the towels to be cleaned with detergent A or B. So we see here the random assignment. So the group is the towels, the random assignment is through the coin, and then we compare how clean they are. The cleanliness is used on a scale of 1 to 10 of the person who does not know which detergent was used. So you can see here there's also an element of blinding. We don't know which detergent was used, so the person who's comparing it, or in this case the researcher most likely, this is a single blind. We already see there's blinding, so this is some fun stuff you can also investigate. The manager continues the experiment for many days. Which of the following describes the manager? So as you can see, we made it clear. I've explained clearly there is random assignment. So we eliminate E. This is not observational study. Matched pairs design? No. It might seem like it, but this is misleading because when you say detergent A and B as the pair, you never ever say the pair are the treatments. Big mistake. You cannot say the pair, the treatments are the pairs. Randomized block design with the washing machine as the block. The thing that's doing the cleaning is not a block. There's only washing machines, so you're not really blocking off of the washing machine. So C, D, E are just totally wrong. Randomized block design with detergent A and B as the blocks, no. The treatments are never, ever blocks. Guys, I don't want you on your exam or anything to think that a treatment can be a block. A block is based on a characteristic that is intrinsic or inherent that is already present in a population before. Therefore, that leaves just A. It is a completely randomized design. B is wrong, C, D, E. We've made that very clear. It's answer A. Did that make sense? Did that explanation make sense, guys? Awesome. Let's go. Let's move on. Came back in the middle of this, but yeah. Okay. Awesome. So now, the last thing. Oh, whoops. Whoops. Solve the FRQ. Go for it. Do your thing. I'll give you guys... What do you mean no? You gotta practice. 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 I will give you guys 15 minutes. And then we'll go over it for like 20. That leaves 15 minutes, and that'll be 2 hours. Sick. Awesome. I stopped recording? Don't worry, I'm still recording. I got this. Took a screenshot of the answer. No. Don't look at them. Please. Don't look at them. Solve them on your own. Please. You gotta be academically honest. Oh, you lied. Okay. Oh, my PC's pretty hot. Oh no. I pray to God that the recording isn't laggy. Please don't be laggy. Please. Okay. Are you guys solving? Yes? Okay, you guys have 13 minutes. Okay, I need a break. How many units will be covered? 1. We're covering just Unit 3. Don't worry, if you missed a lot of the lecture, you can still watch the recording. There is going to be a recording. I'm recording, and it's pretty thorough. What's nice is that I didn't need to turn on my webcam, so if the transition between the slides is laggy, no problem. Of course, bro, I got you. I'm recording these things. Of course, bro. No need to worry. You already answered. You gotta answer B and C as well. Yeah, remember. Guys, solve it on your own. Don't look at y'all's answers. Of course. What's nice is that you can take my lecture and you can put it into something like TurboLearn. And I think my explanations are clear, and so it'll annotate everything and it'll give you notes and stuff. So that's pretty neat, you know. For the people that are here, remember, use your notes as assistance. My lecture slides are not posted. I'll post them when the session is done. What else do I need to say? What else? What else? When are you doing CSA? I'm not doing CSA tomorrow. I'm doing it this weekend. Oh my god. How do you say your name again? I forgot. Thank you for sending out the lecture form. When will we be posting them? Right after the session is done. So literally the moment we finish, you'll be able to see the recording. Where? The lecture schedule. Dragonfire being really helpful with these. Sending these over and stuff. 12 minutes remaining. Just solve. But we can move on earlier if you guys need to. If you guys want. Yeah, I'm done? Cool. Awesome. Let's see what General has in store for us. I'm just gonna... How do I get better at CSA for the logic part? Look, I'll try to answer your questions in DMs. I don't know what you exactly mean. And I don't want to talk about CSA because it'll be confusing. This is a stats lecture and I'm recording it. That's one part. Remember, do B and C as well. Don't forget. People are answering. Yeah, you're doing a good job. I'll just tell you that. I think your answers based on just skimming look very good. So well done. Yeah, it's not too hard. It's a good FRQ, but it's not that. Buying a graphing calc? Yes! Do so. Because you might want to make box plots, you might want to make residual plots if they're present on the test, you might want to do stuff. Very good. You know what I recommend? I'm going to turn on my webcam. I don't know if it shows, if it actually works. Oh no, I gotta fix it. Hold on. Oh god. Okay. Can you guys see? Is it laggy? No, it's not face reveal. Get this. TI-84. This is your bad boy. You gotta get this. This is the best graphing calculator. You can do so many things. You can do calculations. You can do normal CDF. You can do anything. TI-84 is the best calculator for every AP, for every math and science AP. So get that. You gotta get your good graphing calculators. So yes, you gotta make sure of that. Well, I was about to stop the recording. That would have been a nightmare. Oh, that would have been bad. I have no money. It is expensive, but it's worth it. It is worth it. Trust me. I think you guys did a pretty good job. I'm proud of you guys. Very good answers. They're all right on the money. Right on the money. Do you guys want me to move on? Did you guys have enough time for this? Go ahead. Let's make a poll for this. Let's just have some fun. Make a poll. Should we oops. Jump to present. This is very outdated. Wow. Create poll. USA. Jordan. Move on. Thank you. You guys are very helpful and very supportive. I really appreciate you guys. Wow. Everyone wants to move on. Let's do it. Wait, actually, let me vote. Wait for a few more people. 9. No? Who's saying no? Okay. Please, everyone votes. We have 7 minutes left for this allocated. Egg. Okay. We're moving on. Yay. A. The criteria summary. This is the criteria. For the newer exams, it looks really nice. The scoring guidelines are awesome. For A, you gotta state that the journal results in bias and explain that bias. So as y'all did, or as you guys did, you seem to have done a good job. Well done. Dude, because everyone else said we need to move on. The majority takes the lead. It was a very big majority. I'm sorry. So as we can see, like from what y'all explained, or from even others explained, what you can say, the journal introduces response bias from being dishonest in their journal. So yes, they could lie about what they report. They could exaggerate. There could be self-reporting bias. They could over-report the amount of miles they walked. Say, oh, I walked 100 miles today, when we know that's not true. No way you walked 100 miles. Or you could under-report the miles. You could say, oh, they might have forgotten. So if they really walked 50 miles, they could say, oh, I walked 25. That's really bad. And they could also, there could be bias due to estimation and accuracy. So it may not be necessarily response bias, but it could just be honest inaccuracy. They could just say, oh, I messed up, I'm sorry, I don't know, I can't remember. So that could be, instead of using a tracker is more reliable. A tracker is objective, but if you use humans to track, it's gonna be a mess. Total nightmare. B, simply put, representative sample allows you to generalize to the population. Provides an explanation that the use of the representative sample, valid generalized about the target population, refers to estimation or inference levels in target population or an association between that and that. So you gotta also, what is an unbiased inference? There are two types, like I said earlier. So number one, you can either do a random, when you do a random sample, you can generalize to the population, but the other unbiased inference is that when you actually do randomized assignment, you can actually infer causation. So that's an unbiased inference. So here, or inference for cholesterol levels in the target population, or an association between cholesterol levels and amount of walking in the target population. Okay? See why we can't infer causation. We cannot infer causation right off the bat. Why? You guys understood it well. Because this is not an experiment. We made it clear, if it's not an experiment, you cannot infer causation. So if we just observe the people and do no random assignment, you don't need to even read the question, observational study. Or just say, causation cannot be made. Boom. You cannot make causation. This is not an experiment, and you got to justify why it's not an experiment. Because there was a lack of random assignment. And because of that, because it's not an experiment, there are confounding variables. So that means that there's a lack of control of them, and that means you don't know if the independent variable actually caused the dependent variable. So if you don't know if the treatment actually other things, so if you go back here, so research of walking cholesterol levels in adults, so you don't know, you can't infer, you can't make a proper inference, right? So that's it. Did that RFRQ explanation make sense? That was just a quick overview, because I think everyone understood. Yeah, I know. Yeah, it's pretty crazy. But good thing you guys the majority of you guys solved it pretty fast. So you guys know what you're doing. These kinds of questions, they might take long for some people, but you guys seem to be know what you're doing. So you guys went fast, so well done. Props to you guys. I'll kill switch. Yeah, you got an exam. Oh, he's not here. It's okay. 15 minutes around. It's actually 13 minutes. What's the curve to get a 5? I'm not exactly sure. We can go over that probably together real quick during the Q&A. So we'll save that question for the Q&A. I'm just going to save that. Someone remind me to do that at the end, because that's a pretty valid question. What is the next... Okay, guys, save that for the Q&A. But did the FRQ explanation make sense? Because you can ask your questions in a bit. We're done, basically. The FRQ explanation make sense? All right. Now that we're at the end, I'm going to send this one final time. And I expect everyone to take the time to just fill it out. It literally takes 5 seconds. It doesn't take long. Trust me. So, yeah. Yeah, lecture feedback form. Okay. We're done. Now I'm just going to go through some quick review sources. You can either do AP Classroom. AP Classroom, if you're not self-studying, you can either do MCQs, FRQs, anything. How to respond if I missed a good 1 hour chunk? You don't have to. If you missed a lot of it, you don't have to. But you can go off of based off of what you've seen. You can watch, but you don't have to necessarily fill it out. So you can, or for further review, of course, I have to give the plug because this is a part of 5Hive. You can see the logo here. You can do 5hive.org. You can use that That's a good resource. Stats right now has some like practice tests, I think, for Unit 1, 2, 3, 4. There's some good practice tests on there. My website articles for Unit 1 are going to go on there pretty soon. So check those out. 1.1, 1.2, 1.3, and 1.4. I made those. You can also do College Board's review playlist. They have a good YouTube videos on some MCQs, FRQs. You can solve them on your own. They give some good sample ones for you to do. Crackit has some good questions. Yeah, they're pretty good. I haven't really used it, but I'm pretty sure they're pretty decent. They're not half bad. Advanced Kentucky Math CS. This is a good review resource my teacher gave for me. It's pretty good for like math subjects like AP Stats. It also has videos for CS. Like they have a whole playlist, AP Stats review sessions, and it's up to date because the CED hasn't been updated since 2020, and they made these videos in like 2020, 2021, so they're pretty good. You can also use Khan Academy. They're excellent MCQ practice, but they don't have FRQs. But then for the FRQs, my personal recommendation, do the AP Stats exam questions. Like I pulled the majority of my FRQ questions from there. Do all of them. They're very useful. You can scour them to find the proper questions. Which ones do you recommend most? Which resources, personally? AP Classroom, very reliable. The MCQs, you know what you're getting. You know that they're from College Board. You know they're going to be actually on the test. They're not going to lie to you like that. That'd be really bad. The College Board review plays. The College Board resources are good. I would absolutely recommend 5Hive because 5Hive is really good. Volunteers are really good at doing materials and stuff. So you should use 5Hive. Try it out. Khan Academy, it's pretty good as well. And then the exam questions. I haven't tried College Board review play. I haven't tried the Advanced Kentucky. You can try it out for yourself, but the rest are definitely things I recommend. But these are all just some extra resources. Yeah. Okay. So, like I said, fill out the lecture feedback form if you haven't already. If you're still here, if you attended the whole thing, congratulations. You're very resilient. You have a good attention span. Do you need to pay for 5? Okay. Q&A time. Let's go over some of the questions you guys asked. What's the score curve to get a 5? Let me test that out for you. I'm gonna go to the score calculator. You guys can do that as well. Albert AP Stats curve. If you go here, score calculator. So if you go here, you just increase that. The lowest score you need to get a 5 is 63. So, the timer's ended a while back. So you gotta get 63. That's not bad. Light work, yeah. You're fine. So you gotta get 63. That's as a good turn. Yeah, we're so up. Okay. Does that make sense? Yeah, hold on. I got distracted. I was just looking at something. My bad. What other questions? Yeah, what other questions? Curve to get a 5. We already answered that. We already went through that. Light work. Starting review today for stats. Oh, yeah, better if you started sooner. But you're doing review now with me. So you're going to get a 5 for sure. I'm kidding. I'm joking. 5Hive, yeah, stuff is work in progress, but soon we're gonna put out a lot of stuff. We're working on it, okay? The 5Hive team is very hard at work to, get out all the stuff. So what if we were to finish the investigative task early? Can we work on previous FRQs? I'm not sure. I don't know if the investigative task is separate, but I'm pretty sure it's along with all the FRQs. But they recommend you spend more time on it because it's way longer than your average FRQ. No, believe in yourself. Come on. 10 days, an hour daily, good for 4 or 5. If it's 10 days, I recommend you do way more. Because you gotta cram a little more. If you review earlier, you can review less. You can do an hour a day. I started reviewing. You know how I'm reviewing? Making these lecture guides is review for me. And also, AP Stats is not that hard of a class for me, so I think I'm good on that. If you guys have any questions, you feel free to ask in DMs or stuff like that, if I don't answer them here. For Unit 3, my bad, I already missed it. What's the drawing experimental design thing? Let me just show you. My voice is really tired. I don't know if I can explain them again. So let me just show you. These are the different experimental methods. So you have, firstly, completely randomized design. Hold on. You recommend installing GPT-4 on my TI-84? No. You would get kicked out of the exam room. So don't do that. Don't do that, please. That's not really possible. Okay, so the, yeah, those things. So you have complete randomized design, randomized block, matched pairs, and yeah, that's it. That's all it is. That's all the way it goes. Do we just have to write random assignment? You have to explain it really well. You have to explain it in detail, and if it helps you, make a graph. A graph is just for you mainly, but you mainly have to explain. I didn't do calculus so far. The book hasn't introduced anything too hard. Is that? Yeah, no. There's no calculus on AP Stats. You don't need stats for calc for AP Stats. Don't worry, no problem. You don't need calc. There is zero calc. The highest level of algebra you need is algebra 2, pretty much. It's create easy level modification to do that. Yeah, exactly. Yeah, you need to connect to internet and stuff, exactly. Yeah. Hold on, since we're doing the Q&A, let me just open it to the chat directly for the lecture. Let's just go to Discord. Let me see this a little bit. Okay. Can you guys see my screen still? Also, if you need ChatGPT, yeah, that's true. It's too late to drop out. Just take the exam. Whatever you get, you get. But I really want everyone to get a 4 or 5. It's really not that hard. You just gotta lock in and just know your content, and you gotta be good. Oh, hi, Nit. How you doing? I have his light work if I need. Yeah, you just gotta make sure you don't mess up the MCQs and explain everything at the FRQs. One of my old teachers said it's like eggs in a basket. You gotta claim all the points. You gotta collect. If you don't know how to solve something easy, get your free points. You gotta, like, eat them up. Just collect. Nah, bros. No, to be fair, the teacher who said eggs in a basket, he's pretty old. He's, like, in his 60s. And he's retiring next year. Heisenberg? No. It's my, yeah. No, it's not Heisenberg. Not a chem teacher. No, it is a chem teacher. Does he reside in New Mexico? I don't know. No, he doesn't. Then I have to communicate with my teacher. Does anyone have any more questions? Is this really going in the recording? The Q&A, yes, it is. This end part, yes, the Q&A. Don't worry, you don't have to watch it, but it's good questions. But if you guys don't have any questions, we can just end the session right now. Yeah, exactly. Imagine. Again, last call to fill out this. Last call to fill out. If you're watching this in the future and you're trying to review, you got this. We all believe in you. Don't forget to answer my DMs. Yes. All right. I didn't see it. Do it, or you're getting a 1. Don't fearmonger people, but do it. Do the lecture feedback form. It's very useful. Really good for me. You know. Okay. Does this affect your pay? I'm not paid. I'm volunteering. You're so cool. I know. Gonna make use that. Yeah. By the way, AP Stats is fully virtual, I'm pretty sure. Actually, I think the FRQs are hybrid. Easy college app hours. I know! That's the point. FRQs are on paper. FRQs are written. Yes. Anyone have any other questions? Remember to fill out the feedback form and everything. No? If you guys don't have any questions, it's so unnecessary. How much time do we have? We're done. We can end this right now, but we have technically 30 minutes before I have to close it out. So it's because the lecture's been going on for like an hour and 28 minutes. So we can end early. Thank you for the lecture. Of course, anytime. You can watch the recording if you didn't watch the full thing. By the way, if you're about to leave, remember, if you haven't filled out the lecture feedback form, do fill it out. Nishal, you can send it again. When's the next lecture? Tomorrow, same time. Oh, hold on. No, he met with exam. Yeah, Desmos doesn't allow you to do all significance tests that you need. Really? No, I think it allows. Oh no, Desmos. No. You need a TI-84. You need a TI-84. Wait. Go to sleep. It's 11 p.m. How do you know my time, man? Stop. Stop stalking me. Too early. Crazy. I live in Jordan. I live in the Middle East. So yeah, he lives in Jordan. Yes, thank you, Nitz. Live in LeBron. You guys take EPs there? Yeah. Masha Allah. Wait, are you Muslim? Alhamdulillah. Assalamu alaikum. Profile picture make more sense. Did you do Ramadan? Of course. Of course. I did. I absolutely did Ramadan. Tesla and stuff. Whoa, whoa, whoa. That's a little creepy. Okay, are we done here? Do you guys have any more questions? It's not Ramadan challenge. Astaghfirullah. Do you guys have any more questions? Okay, someone make a poll. Do you guys want to ask more questions, or are you guys have no more questions? Someone make a poll. When this means La ilaha illallah, it means I bear witness that there's no God other than Allah. So yeah. No more oh, everyone's leaving. I found the mob spawner. Bye. See you guys. Okay, everyone I think has their questions. Okay, you guys can leave. Double your session. Thank you. How about the events? Yeah, I saw it. It's like a Minecraft thingy. That sounds great. Alright. Of course, dude. Please come into the next one. It's gonna be great. Alright. Last to leave. Okay, sure. Do your thing. Join Gen 1. Alright. Well, I'm reviewing. So, goodbye. Bye, everyone. This was great. This was a lot of fun. Bye. Goodbye, everyone. Whoa. Weird gift. Alright. That's it, guys. Thank you for tuning into Unit 3 lecture. If you're watching this from home, if you're watching this not live, thank you very much for watching. Thank you for sticking to the end. If you have any feedback or you want to let me know how you can make my lectures better, please let me know. And I hope this was really informative and for you guys. So, bye. Good luck on your AP. Hope you guys do good on your AP Stats exam. Get 4s and 5s. Yeah, you're the last one. Victory. Okay. Alright, I don't want to make this too long. Okay, I'm gonna end the recording. Bye.